Welcome to Calculus. This is going to be the first section that we're going to cover on limits. What we're going to be doing here is we're going to be finding limits graphically and numerically. So this is going to be our brief introduction to limits. So this is at first it can be complicated to understand what limits are. It is the introduction to calculus, so the material does start to get a little bit more college level here. But let's first look at the vocabulary term here. It says a limit is the value y, okay, the value y that you get of a function as x approaches a given value. In other words, if I told you that x is approaching, say, 5, as x approaches 5, you would look at what is happening on a graph as x approaches 5, and you'll be looking at it from both sides of that number. Now, make sure you understand the difference between your values here. X values are your horizontal values, your y values, or also f of x values. Keep in mind, y and f of x are the same thing. An f of x value and a y value are the exact same thing. Okay? So what you're looking at here is this is the basic notation of what limits are. This says the limit as x approaches c. C is just a value of f of x. F of x will just be your function, will equal a number. Okay, as x approaches c means what is happening to your value, to the y value of your function, as x gets really, really close to this value. So for example, we have an example here that's x to the third minus 1 over x minus 1. So because x minus 1 is on the bottom, x is not allowed to equal 1. But we are going to still find the limit of our function as x approaches 1. If you just tried to plug x equals 1 in, you'll get undefined, but there still is a limit to this. In other words, we're going to, starting off, we're going to use a table of values, and we're going to approach 1 from the left. Okay, so we're going to call this x approaches 1 from the left. Sorry about my handwriting, but you can hear what I'm saying. That's x approaches 1 from the left. And over here, we have x approaching 1 from the right. So basically what we've done is we've created all of these values that will allow us to see what's happening as we get closer and closer to 1. So this is starting a little bit further off, and you can see these numbers here are getting closer and closer to 1. If we were to plug these into the function, I've done that for you, these are the values we get. We get 2.313, we get 2.710, 2.970, and then 2.997. We don't know what this is because if we plugged 1 in, we wouldn't get a value. And then on the other side, we get 3.003, 3.03, 3.310, and 3.813. So you can see as we get closer and closer to 1, you should be able to make a determination of what our f of x is approaching. So down here, this is what our f of x is approaching. And we need that value to approach the same thing from both sides. So f of x is approaching 3, because that's really close to 3, that's really close to 3. So f of x is approaching 3 from both sides, so therefore 3 is our answer. Okay, so what I want you to do is try this one on your own. Do the best you can. All you're doing is plugging these values in. Use an online calculator if you need to, or use the calculator that I've assigned you. That'll make it a little bit easier. All you're doing is plugging these values in, and I want you to see what you come up with as you approach there. So hit pause on the video, do the problem on your own, and when you're ready, hit play, and we'll go over it real quick. Okay, so putting these values in, you should have gotten the values that I have written here, 0.75, 0.9, 0.99, 0.999. 1.001, 1.01, 1.1, 1.25, and then you should have noticed that these values from both sides are approaching the value 1. So the limit of this function up here is equal to 1. So now we've talked about constructing a table of values. There is two other ways for us to find a limit. One of them is to use a graph. You can always use a graph to find a limit, and then you can also use algebra or calculus, which we will do in future sections. Right now we're going to get into the graphing portion of this and kind of show you how you would use a graph to find a limit. So we're going to start with this. This is a piecewise function. Now I know you don't have a ton of experience with piecewise functions, but basically what this is doing is this is telling you what f of x is equal to based on conditions. So it's saying f of x is equal to 1 if x is not equal to 2. In other words, it's saying that f of x is going to be equal to 1 at every point except for x equals 2. So when I graph that, if f of x is equal to 1, that's the same thing as saying y equals 1. So y equals 1 is going to be the horizontal line right here. And we're going to say that it's going to be at every single point except for x equals 2. So when we draw that graph, it looks like that. Y equals 1 at every point except for x equals 2. And then they're saying that y is going to be equals to 0 when x is equal to 2. So therefore, we have a point right here. So it's just a single point. So now you look at this graph and it says find the limit of f of x as x approaches 2, where f is defined as, and then we have our function. So we've graphed it. We're going to use the graph to find this. Now, the typical response might be say, oh, the limit must be 0 because x is equal to 2. No. The limit has to approach the value. It says as x approaches 2. In other words, what is the y value as x approaches 2 from both directions? Okay, so that's this point right here. And that value is 1. So therefore, your answer here is 1. All you're looking for is find the limit of f of x. F of x is the same thing as y. So you're looking for a y value. What is your y value as you get really, really close to 2? Okay, in this case, even though there's a hole and even though it's undefined there, it's still the limit because it's approaching the value of 1. Okay, next thing down about limits that do not exist. There are limits that do not exist. Okay, so what we need to pay attention to here is understand the definition of this. It says if the value when approaching an x value from both sides is not the same, the limit does not exist. In other words, if you are approaching one y value from the left and then approaching a completely different value from the right, the limit will not exist. So let's do that. Let's show you how this works in these two examples right here. We have the limit as x approaches 0 of the absolute value of x over x. I'm just simply going to graph these real quick. Okay, so this graph looks like this. We have a line down at -1, and then when it gets to here, we have a hole. And then on the positive side, we have a hole at 0 again, and it goes across like this. So that's what our graph looks like. In other words, 0 is undefined, so we have a hole at both zeros. And then down here, all of our y values are going to be negative because the x value is negative, and all of our values over here are going to be positive. So it's kind of like a jump in our graph. So if you notice, it says as x approaches 0. Well, if you look at this graph, as we approach from the left-hand side and we approach from the right-hand side, it's two different values. From the right-hand side, it's equal to 1. From the left-hand side, it's equal to -1. Because of this, we say the limit does not exist. Okay, because the y values are different on both sides of the limit. Okay, it's very important what this says. Okay, don't just look for a gap in the graph. You need to make sure that you are approaching the value that it tells you to. In this case, it's 0. So we're approaching x equals 0, which is where that jump is. Okay, on this graph right here, same type of idea, just a little bit different because the graphs don't look exactly the same. This graph looks like this. So we have these graphs that are, we call these asymptotes. Both of these graphs go up to infinity. This is kind of the same idea. Because they're not going to a defined point, even though they look like they're going to the same thing, we still can say that this does not exist because they are going to an undefined point. It's an undefined number, and they're not converging on the same number necessarily. So we say that this does not exist. We will learn something a little bit later about infinite limits and how we can change that. But those are two examples of things that do not exist. Okay, so those are the first two. It says approaches a different number from the right side as it does from the left side. That was this example right here. Okay, a second way for a limit not to exist is it increases or decreases without bound. That's this example here. And the last one, which we didn't talk about, it says f of x oscillates between two fixed values as x approaches c. That is sometimes in trig, with trig functions, sometimes it jumps between positive and negative numbers without any rhyme or reason. It just oscillates. And because it's jumping back and forth, it cannot converge on the same number, so it won't exist there. We'll see some examples of that in the work that we do in class. So that's it for this section. Hopefully this is a good overview. If there's been an Edmodo quiz assigned, make sure you do that. Just use your notes to do that, and I will see you in class.